This is going on page 47 when we're done. Okay, this is sketching polynomials. We're not graphing them, we're sketching them. A little bit different because we're not going to have all the specifics we need to get a specific exact graph, but that's okay. We're going to use what we can find now. The other stuff requires skills that we don't have yet. So here's a list of things to do, but before we talk through the list, we're going to jump to the bottom. In behavior again, right? We've had to write it out a bazillion times. I made you write it out twice yesterday. Today I was trying to be nice and I actually put some of the stuff in there for you already, but then I messed it up. Where's my mistake? I put infinity twice. There's no negative. We can fix that as we go along though, so it's a minor thing. All right, so we're looking at end behavior, right? So if I have an even degree polynomial, that means that the ends are the same, right? They're either both up or both down. If it's even degree with a positive leading coefficient, is it up, up, or down, down? Up, up. So it looks like this. Not necessarily on, well, I guess it would have to because it's continuous. But, you know, you may have both arrows on one side of the y-axis. That's possible. So then as x approaches infinity, f of x approaches infinity. Add the little negative sign there because I left that off. And it also approaches infinity. Okay, so again, even degree, but this time a negative leading coefficient. So they're still the same, which means this is down, down. And this would be negative infinity. Add the negative there, and then negative infinity. Odd degree, positive leading coefficient. If it's odd, they're opposite. So is it down, up, or up, down? Down, up, right? We're up on the positive side of the x-axis, positive leading coefficient. So as x approaches infinity, f of x approaches infinity. Make sure you add the negative. I was the victim of cutting and pasting and not fixing. And then this should be negative infinity here. All right, so then this is just a reflection of that in the x-axis. So this would be up, down, and this would be negative infinity. Make sure you add the negative there and then the infinity, right? Okay, everybody get within behavior because that's part of what we need there. All right, so let's go back up to our list because we're going to use this up there. Here's a little list of what to do, okay? We got to find the x-intercepts, which are the zeros, which is something that, excuse me, easy for us to do. If it's not factored, we need to factor it. Most of what you have today will be factored for you already. We'll get to where we have to factor them a little bit later. Then I also need to find the y-intercept, which would just be the constant if it's in general form. But like I said, most of these are already factored for you, so they're not going to be in general form. Then we want to notice if the polynomial has an even or odd degree. Okay? And you look at the highest degree, not necessarily the first if it's in general form, but the highest degree. Okay? And even or odd determines, you know, your end behavior, which also does the sign. So these three things here all kind of go together, right? So these three things here, oh, not what I'm trying to do here, go together. We got to look at the degree. We notice the sign of the leading coefficient if it's positive or negative, and that helps us to determine the end behavior of the polynomial. So if the coefficient is positive, if it's even, then it's up, up, right? If it's odd, then it's down, up. And if the leading coefficient is negative, then it's down, down for even, and up, down for odd. Okay, that makes sense? We all good? Okay, because those are pieces that we're going to need there. Then the next thing we look at is whether you have any factors with a degree higher than 1. Right? So when we factor things out, if we have a factor that is a degree higher than 1, then special things happen at those x-intercepts. If you have an even power factor, so even power of a factor, not necessarily an even power of the polynomial. The polynomial could be an odd degree, but we're talking an even power of one of the factors. Then it gives a relative min or max on the x-axis. So what this equates to is basically a bounce. It's going to bounce off the axis. Okay, whether it's coming up from underneath and it just hits it and goes back down, or from the top and bounces and comes back up. If we have an odd power greater than, let's just say 1, okay, so an odd power factor greater than 1 locates a point of inflection, so your point of inflection on the x-axis, which That would be a point of inflection or a wiggle. So you can either wiggle or bounce if you have a factor that has an exponent greater than 1. And I'll re-explain what that means once we actually look at some of the examples, because that confused some people last period. All right, and then we draw the continuous curve. So this is important too. This is a continuous curve. Okay, there's nothing jagged about it. It's not a zigzag. Okay, everything's curvy and smooth. We observe proper behavior at each 0, y-intercept, and end behavior. So we're not going to be able to find the actual max and mins right now. We don't have the skills for that. But we can plot the zeros on the x-axis. We can plot the y-intercept, and then we can get our end behavior and get our polynomials sketched in. Okay, let's look at how that's going to happen. Here are the things that we need. So this is already factored for me. That's nice. If not, we would have to factor it. So what would you say the degree of this polynomial number 1 is? What's the degree? 3. If I was to multiply it all back together, what would your highest exponent be? 3. So the degree is 3. Then what's the name of it, which is what some of y'all were trying to give me? What do we call that? Cubic. Okay. So this is a cubic function, right? All right, so our end behavior, up, up, down, down, what is it? Down, up. It's odd, so it's opposite, right? And then that would have to, and it's positive, so it's going to be down, up. Like so. Okay? Are your x-intercepts at this point going to be easy or difficult to find? Easy. Okay? So this one would give me, and since it says x-intercepts, write them how? Ordered pairs. Okay, so the first x-intercept that I see would be what? -1, 0. Then what would the next one I see be? 3, 0. And then the next one I see is -4, 0. Right? Those are my 3 zeros, yes? Not necessarily order, it's the order I see them. That's a little bit better sometimes, that way I don't forget something. Now, your y-intercept. This is not in standard form, so I can't just use the constant. It's not that difficult to find. Your y-intercept is when x is what? 0. So that means that y is going to equal, when I substitute in a 0, that's going to give me 1 times -3 times 4. So what does that give me? -12. So this is going to be 0, -12. So to look at my x-axis, I'm only going out to -4. So I can put some little hash marks here. And I can go 1, 2, 3, 4, 5. 1, 2, 3, 4. I went ahead and did 5 because 5 fit, but if you space them out enough for 4, that's fine too. And my x-intercepts, I have one at -1, 0. I have one at 3, 0. And I have one at -4, 0. All right, so I've got my x-intercepts. I also need my y-intercept. Can I make the scale on my y-axis the same as I did the x-axis? I can't, because -12 will be like way down here. But it doesn't matter. I don't even have to put a bunch of hash marks. I don't even care what they are. Just -12, boom, it's right about there. Okay? Boom, that's right. Oh, and I could, this is -4. This is at -1, and this is at 3. Okay? All right, so then I've got to draw this in. My end behavior tells me how I start, right? So I'm going to start from infinity. Now, when I come up through this this x-intercept, I'm going to have to come back down through this one. What I don't know is how far up I go. I could go up a lot, or I could just go up a little. I don't know, because we don't know where our maxes are, and that's okay. That's why we're not worried about the actual scale here. So we're going to go up, hit that. I have to come back down. Now, when I come back down through here, I have to hit that -12, because that's my y-intercept, before I can come back up through 3, like so. And then my end behavior should match what I said at the beginning. Because just because you start where you said you were going to start, if I ended up and I was pointing down, something's wrong somewhere, right? So if you can't get it in there like you know it's supposed to be and something's not working out right, there's a mistake somewhere. Now, this y-intercept here. It's possible that that y-intercept is a relative minimum, but we don't know. Okay, so it could be, and depending on how you're sketching your graph, it may end up looking like that's maybe what it is. But remember, you don't know how far it goes down anyway. So just know it could be the the minimum, but this is not necessarily a minimum. It could be, but we just don't know. Okay, so you don't have to force it to, because sometimes when students are drawing these, they try and make that the minimum, and it's not necessarily the case, and it's not really to scale anyway, so we don't really know. Okay, everybody okay with all that? We good? All right. Okie dokie. So then, let's look at number 2. So what is the degree here for number 2? 4, right? This would give me an x squared, and then x and x would be, the degree would be 4? Yes? Okay. And which means we would call it a what? Quartic. Okay. All right. So it is an even power. Is it positive or negative? Positive. So what does my end behavior look like? Up, up. So there's my end behavior. Okay. Now, my x-intercept, what will be the first one that I see? 0, 0, and then 2, 0, and then what? 6, 0. Okay. Now, on the front, in your little list there, number 6 says, notice if there are factors with a degree higher than 1. This is factored out for you, right? These are our intercepts. These are our factors that I have written like this. I could write this out as y equals x times x minus 2 times x minus 2 times x minus 6. Is that the same thing? Yes, okay. But it's better to write it like this, yes? So I have 4 factors there. That's where my quartic comes from, right? I just have some of them combined. So since this factor here has an exponent that's greater than 1, something special happens at that point on the x-axis, right? It's even, so what happens? It bounces. So it's a relative maximum or minimum. So here at this 2, 0, I'll put a little star there. This is going to be a bounce off of my axis. Okay? Bounce is not the official term. It's a relative max or min, but it bounces off the axis. That's what you need to make sure you know. Okay? And if you have room, either on your notes or your homework, to like actually write bounce or something right above it, you could, but I don't really have room, so that's why I put it out there. But you want to mark it somehow for yourself. And then I need to go find my y-intercept. So what's my y-intercept going to be? It's real easy. What is it? 0, 0. If you have an x-intercept of 0, 0, your y-intercept is 0, 0. Because as soon as you substitute a 0 in here, guess what? The whole thing's 0. You're overthinking things. 0, 0. Told you. All right. So then I'm going to, oops, I don't, because I need to scroll yet because I can't see. I'm going out to 6, so I'm going to go 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So my x-intercepts, I'm here at 0, 0, at 2, 0, and at 6, 0. So even though it's a quartic, there's only 3 points on the x-axis, right? And there is, my y-intercept is 0, 0, so I'm only plotting 3 points, period. My end behavior tells me how I start. So on the far left, I come down from infinity, right? So I'm going to come down. I pass through 0, 0. When I go back up to 2, I bounce off the axis and come back down so that it looks like this. Okay? Kind of like a weird W. But remember, as you're doing it, this right here is a curve. It's not like I went to a point and came back down. It's not a very smooth curve or a good curve, but it's a curve there. Okay? We good? Because it's not an actual bounce like if you were to, throw a ball against the wall and see how it like went there and right back. I mean, it's kind of, it hits it, but it comes back down and it's a curve. Okay? We good? Any questions? All right, so I want you to get the stuff filled in for number 3. Okay, get all this stuff filled in. I'll help you with the graph. Let's make sure all that's right first, but I'll give you a chance to get this done. I'll give you a few minutes. All right, I'm going to have you pause on what you're doing real quick because my picture wasn't that great, and I think it has thrown some of you off. I'm going to redraw it. Here's what I have seen. Don't draw this because this is wrong. Here's what I saw when I was walking around. There are quite a few people that have something like this. Comes like to a point and then comes back down like that. That is not okay, okay? Because remember, these are smooth curves. So let me redo my picture better. when I come down through 0, 0, it's going to come up, and it's a curve right there. It's come like that. There's no pointy anything, okay? It's a curve there. Well, their graph looked more like that almost, and like that's not really what's happening because it's a curve there. It should be a curve right there at that point. Does that make sense to you? So, and again, this isn't an art class or anything. I'm not criticizing that part of it because obviously mine looked like junk. But just make sure that you're making that honest effort to make it a curve and that nothing else weird is happening there. Okay. All right, so let's go ahead and look at number 3. What is the degree? 5. So we would call it a what? Quintic. Okay. And then in behavior would look like what? Up, down. This is negative right here, so this would be up, down. Okay. My X-intercepts are 3, 0, negative 4, 0, and negative 1, 0. Anything special happening in any of them? Yes. At 3, 0, this right here is called a what? It's a wiggle. It's the point of inflection, which is your wiggle. Okay. Then your Y-intercept is going to be negative times negative 3 cubed times 4 times 1. Right? So what does that give me? $108, positive or negative? Positive, okay? Because this becomes a negative 27, but then times the negative, that's a positive 27 times 4 is going to be 108. So it's 0, 108. Okay, everybody good? So then I go and I'm going out to 4. So let's see, 1, 2, 3, 4. 1, 2, 3, 4. Everybody understand why I know it's a point of inflection or a wiggle? Ask me a question, because that was confusion last period, and nobody asked me questions, and then I was mad because they were confused, but they didn't ask me questions. Are we good? Okay. You've got to speak up. All right. So at 3, 0, I have a point. At negative 4, 0, I have a point. And at negative 1, 0, I have a point. Right? Now, I'm going to start by doing this wrong. So I'm doing this wrong on purpose. Do not write this down because it's wrong. Because last period, there was a few people that had negative 108. Maybe there was a few in here too. I don't know. But here's what I want to show you is that if you got negative 108 or anything else on here is wrong. So don't draw this because I'm going to erase it. If I say, okay, well, I'm here at negative 108, right? So negative 108. And I'm going to draw this. I start from up here. Okay, so my wiggle is over here. There's no bounces. So I'm going to come down here. I go up through this point. Well, I'm going to have to go up and then come back down into the point of inflection, right? If I do this, am I going to hit that negative 108? No, there's no way for me to get that on there, right? Now, if there was a bounce here, then maybe. But do you see how as I'm going, like I can't even make what I have work? That's clue number 1 that something's wrong. Maybe it's not your Y-intercept that's wrong. Maybe it's your in behavior that's wrong. Maybe it's something else, right? Does that make sense? In this case, we know it's the Y-intercept because I deliberately put the wrong one on there. But just so when those things like that happen, you need to kind of go reevaluate everything that you have. Make sure that, you didn't miss a bounce or a wiggle or you didn't miss the in behavior, something like that, okay? All right, so let me redo here. Okay, the correct point is positive 108, like so. So now, my in behavior, I start up here at infinity. There's no bounces, but I have a point of inflection here, which sometimes is tricky, I know. So we come down, go back up. I have to hit 108, and then I have to have a point of inflection. You have to kind of slow down and then, speed back up. Your point of inflection, it needs to be an honest effort to make a point of inflection. I can tell if you just went straight through the axis or if you actually tried to make a little wiggle there. So again, just whatever. It's not an art class. And if you kind of miss your points like I did, you just make the points a little bit bigger, and then it's all fine. Okay, okay, we good? Because we're sketching. It's not a super accurate, perfect graph. It's a sketch to get the pieces in there that we can do right now. Okay, we good? Any questions? All right, you do the next one. Get the next one started. right, do you agree with everything I have so far? Yes. Okay. So we have on both factors that I have an exponent greater than 1. So at negative 3, 0, what happens? POI, which means at the axis you wiggle, right? And then 3, 0, this one has an even 1, which means that one is a bounce or a max or a min. Okay, does that make sense? Yes? Because if it has an odd power, it's a point of inflection. If it has an even power, it's a bounce. Okay, it's odd and even. Just like, think about this. Here's how you remember that. For a quadratic, guess what's happening? You have a bounce. That's an even power. Guess what's happening with the cubics and the odd ones? You have a point of inflection, right? It's the same connection. So odd gives you the point of inflection. Odd, but not 1. I know 1 is odd, but 1 doesn't count. Odd, and then even gives you the bounce, okay? So then my y-intercept, is it positive or negative? Positive. Make that decision first before you get lost in the numbers. Bless you. Because you get lost in the numbers and then do weird things with your signs. It's positive, and it's a positive what? It's going to be 27 times 9, right? 243. 243. Oh, sorry, I'm writing that wrong. 243. What's that right there? And whatever the answer is to that, whatever number you were going to get here, it has to be a factor of 9, right? Because you're multiplying by 9. Did you know that all factors of 9, the digits add up to give you what? 9.
Wait, what?
Look, 27, 2 plus 7 is 9. 243, 2 plus 4 plus 3 is 9. Write them all day. I just want you to think about the factors of 9. It'll just blow your mind. Okay. 81. Oh, my God. All right, so here's 90. All right.
Wait, 9 and 1 gives you 10, though.
No, it's the number itself, not the factors. The number. 9 plus nothing is 9. Yeah. It's all good. All right, so I'm here at negative 3 and at positive 3, and that 243. I'm going to give you a second. I want you to try and draw that in. Good. Let me see yours. Maybe I'll come have you draw mine. Very good.
Yeah.
Very good. Yeah, and that's okay because you don't really know where the max and whatever is. It's some of them are a little funky to draw. So good. If it helps, because here's where I have the issue with the point of inflection. When I'm going from negative infinity, I have a much harder time. It's much easier when I'm coming from positive infinity type of thing. And so even though you're starting over here when you think about your end behavior, there's nothing wrong with starting the graph on the other side, or at least just getting like this part in. Like I would probably have to do that, just otherwise mine's not going to look right, and I know that because I just can't get the shape in there. And then I can continue. I don't know exactly how far up it goes right here or anything like that. I just know it has to go through 243. So it's going through 243, except I'll connect that better. It's going through 243. All right, although I'm backing that up a little bit more because what I had a little hook on there and that was not good. It needs to come this way. There we go. So then I'm heading this direction. We're going to go through 243, and then what happens at this one? We have a bounce. It comes back up like that. So my end behavior, down, up. That wouldn't have happened if I ignored my bounce, right? So if you know what your end behavior is and what's happening at the axes, then you'll be able to get your pieces in there just fine. Okay? We all good? Any questions at all? Not that bad, right? Awesome. Remember to do what we're doing right here in this manner, it has to be factored all the way. Most of them on the assignment are, but not all of them. So if they are not factored all the way, you have to factor them all the way so that all the pieces that we just did works. Does that make sense to you? Okay, good.